Hello, Algebra 2 students, and welcome back to Chapter 3. Today, we are going to be working in 3.5, which is matrix operations. Remember that this one, you're not needing a follow-along sheet. You should be doing your notes in your notebook, along with all the examples, and I will be checking that at the start of class. Here, we're introducing matrices. Okay? In matrices, there are a list of numbers. Okay? There are a list of numbers, such as here I have matrix A. It's denoted with a capital letter. Okay? And it is made up of elements. Okay? We have elements. So if we scroll down here a little bit, we got this idea of a matrix. It's a rectangular arrangement of numbers in rows and columns. It's always row by column. Okay, row first and column. Okay, just like it says there in the dimensions. Again, remember that you are supposed to be pausing these notes to write it down. I am not going to pause the video for you. Elements are the numbers inside of a matrix. Such as, if it says find element A, 2, 3. Okay, so I want A, 2, 3. Well, I know it goes row by column. So I know that this is row 2. Okay, row 2 would be this row here. And then it says column 3. Okay, column 3 is this one right here. So I'm looking for the intersection of those two, which if I drag it over, that is the 3. So A23 is the number 3. Now would be a great time, pause the video, listen to me say that again. Okay, A23 is the number 3. Here's a great time to also pause the video and write down everything that I have up here on the board. Then, once you have it written down, play the video again to listen to what I have to say. Okay, now that you've had a chance to write it down, when you're adding or subtracting, they have to be the exact same dimensions. Okay, they have to be the exact same. Here when I'm looking at this addition, this is a 2 by 2 matrix plus a 2 by 2. They are the exact same, so I can add them. At the end, I will have the same type, 2 by 2. It's really quite easy. You're just adding each individual element. Okay, each individual element. Now, if we started on some examples, again, now's a great time. Pause the video, write down the example I have on the board. Okay? Now that I've given you enough time to write it down, let's see if we can do this first one. Well, let's write down the dimensions. This is a 2 by 2. Why? Because there's 1, 2 rows, 1, 2 columns, making it a 2 by 2. If I look at the one over here on the right, this is a 1, 2, okay, so that's a 2 row. Oh, and there's only 1 column. 2 by 2 minus a 2 by 1. Can I take two matrices of different dimensions and subtract them? Well, no. Not the same dimensions. Thus, not possible. That was easy. When they're not possible, it's easy. We just say not possible. Okay, let's try this one. Again, you have to pause the video and you have to copy it down first. Now that you've copied down the problem, let's see if we can't add it. Well, I always will write the dimensions. This is a 2 by 2. This is a 2 by 2. They do match, so I am allowed to add them. when I go through now, I am going to go through each element, and I'm going to add them up. So here when I'm going after it, I am adding the 3 and the -1 because they're in the same spot. So I have 3 plus a -1. Then I continue this type of pattern. So I have the 0 and the 4. That is 0 plus 4. Five and 2. Okay, that's 5 plus 2. And -1 and 0. That's -1 plus 0. Of course, I realize that most of you can do that in your head, and that is completely fine to do this little tiny math in your head. It is completely fine to do so. Now I think I'll finish it up. 3 plus a -1 would be 2. 0 plus 4 would be 4. And then I have my 5 plus 2 is 7. And my -1 plus 0 is -1. And that would be my solution, which is also a 2x2. Great time to pause the video, make sure you understand how to add and subtract. It wouldn't be any different if I were subtracting except for these. This positive sign would change to a negative, and each individual sign inside would change. Now if we get into a scalar is just some number. I'm taking a number and I'm actually multiplying it by a matrix. When I multiply by a matrix, okay, I will be pushing in every single value. I will take every single value and I will multiply it by that number. Again, now is a great time. Pause the video. Make sure you're getting these notes down. Here's another great time. Pause the video. Write down the example I have on the board. Okay, now that you've had enough time to write it down, I have a scalar. This down here is a scalar. This thing right here is a 2x3 matrix. Thus I have scalar multiplication with a matrix. Okay. Now, as I'm working this thing out, it's actually super simple to do this stuff. I am going to take this 3 and I'm going to multiply it in to every single one. Because I am multiplying it to every single one, I should have a matrix that looks the exact same. I am taking 3 times 0. It goes up top here. Then I go to the next one. 3 times 2. And then the next one, 3 times a -7. After I have that, then I go on to the next, on the bottom, I'll take it into the bottom row. That's 3 times a -1. 3 times 6. And 3 times 4. Of course, I realize that most of you are just going to do this math inside your head. That is fine. If I finish it up here, 3 times 0 is 0, 3 times 2 is 6, 3 times -7 is 21, negative. And I have 3 times 1, that -1, that's -3, 3 times 6 is 18, and 3 times 4 is 12. I started with a 2x3 matrix. I still have a 2x3 matrix at the end. All right, well, let's try this one here with this fraction. Let's try with this fraction. I'm pausing because you should be pausing the video yourself and writing down the problem. All right, now that you've had a chance to pause it, now try it on your own. Pause the video and try it on your own. Okay, now that you've had a chance to try it on your own, I am taking the negative 2/5 in times each one. So when I'm doing this, I'm taking negative 2/5 times 1. Well, that's negative 2/5. I'm taking negative 2/5 times 0. Well, that's easy. That's 0. I am taking negative 2/5 times 3. Well, that's a 3 over 1. So I'm at 3 times a negative 2. That's negative 6 over 5 times 1, which is 5. Across, I have negative 2/5 times a negative 5 over 1. And then I am clever here. I know that this 5 will cancel with this one. It's a negative 1 times a negative 2, which would give me a 2. And there I have my solution. On to matrix operations. Okay. If I allow A, B, and C to be matrices with the same dimensions, okay, and K be a scalar, that's just some number, we have the following properties, which we've studied before in mathematics. Now you should pause the video again, and you should write down all of those properties. All of those properties. So you've had a chance to write them all down. Let's go on and see if we can't put them into use. Okay? Okay, so we have the following matrices. Okay? You should write this down. You should pause the video here and write down these matrices and number 6. You should write down number 6. Because we're going to be doing that one together. Alright, now that you've had a chance to write it down. If you really want to try this on your own, feel free to pause the video right now and try this on your own. Okay, so you've either tried the video or you just like to go through with me. I need to do 4 times A. Okay, 4 times matrix A. Well, matrix A is right here. So maybe I'll do 4 times matrix A first. So that's 4 times 5 minus 4, or negative 4, sorry, 3 and a negative 1. Well, if I work that through, again, that's just distributing. That's a 20, a negative 16, a 12, and a negative 4. That is just the 4A part. Well, what am I supposed to do after that? I am supposed to have 4A minus B. Okay, well, I already know that 4A was this part over here. Okay, well, that's 20, negative 16, 12, negative 4. Then I am supposed to subtract B. Okay, minus, what is B? That's this thing up here. Okay, 18, negative 12. 18, negative 12. Negative 6, 0. Now I just need to do that math. Okay, remember that if I'm doing this, I am taking 20 minus 18. Well, that is 2. And then I'm taking negative 16 minus negative 12. Okay, negative 16 minus a negative 12 plus a positive, that would be negative 4. I'm taking negative 4 minus 0. Oh, that's simple enough. That's negative 4. And then I have 12 minus a negative 6 plus a positive would make 18. Right now would be a great time to try number 7 on your own. Now that you've tried number 7, let's see if I can work it out on the board. First I have to take D. D is this matrix over here. All right, I'll take that. That's 7.20, negative 5.4. 2 2.1, negative 1.9, and 3.3. I am taking this matrix minus 2 times C. And I have my C written in there. So this is the equation I need to do, or the matrix expression that I need to simplify. Here, I can actually do it all at once. If I just look at, okay, this is my first element. First row, first column. So this technically would be D sub 1, 1. I need to take that, which is 7.2, and I need to subtract, I have my subtraction over here, minus 2, my scalar, times C sub 1, 1, which would be, in this case, 1.8. Well, where would that go? Well, it was D sub 1, 1 and C sub 1, 1. So that must be the first row, first column of my new matrix. And then I just continue. If I do the next one here in green, I would have 0 minus 2 times negative 1.5. And then I just continue. At this time, you're going to want to pause the video and write that out for yourself. I'm going to pause my video, and then when I come back, I will have mine written out. Alright, so now I'm back. I have mine all filled out, and this is exactly what yours should look like. If it does not, now is a great time to rewind the video, go back and listen to how I described the simplification of the two matrices. My final step is to just go inside of each of them and simplify it. I don't need to make this part hard. Okay? You have a calculator, you should be using it. Use your calculator and simplify each of the elements inside of our matrix. Okay, now's a great time, pause the video. When I come back, I will have mine filled out. I now have my final answer here boxed in black. I had two 2x3 matrices that I did some operations on, and I ended with a 2x3 matrix. Okay. If you did not understand any of that, you're going to need to go back and remaster that. Again, this should all be copied down into your notes. Well, let's try to get into solving a matrix equation next. This example needs to be copied down onto your notes. You should pause the video at this time and copy this thing down. Okay, now that you've had a chance to copy down the problem, let's talk through it. Here it appears that I have a 2x2 plus a 2x2, which, remember, that thing should give us a 2x2 at the end. And then I just multiply each of their values by this scalar of a 3 out here. Okay? And even if I multiply a 2x2 matrix by a scalar 3, I will still get my 2x2 at the end. So, when I'm thinking through this problem, some things that I want to think about is it says solve. Solve. So I'm looking for variables. If I'm looking for some variables, maybe I should find one first. Right here I see a 5x. Okay? What affects that 5x? What is going to be added, subtracted, multiplied, or divided by that 5x? Well, I have 5x, I have this plus, and then I have this 3 over here. So I have 5x plus 3, because they're both in the same location. That's not all that's being affected. Notice these parentheses. I have parentheses around that. And then I have a 3. And that should equal the element that's sitting over there. So then I have equals negative 21. Now I've created an equation. I should be able to solve this. Okay? Most of you, I think, are going to want to distribute, but me, I think I'll divide by 3 first. I want to get that 3 out of there. I get a negative 7. I have 5x plus 3 is left over here. I subtract 3, I get a negative 10. I divide, and I get x equals negative 2. Okay. That wasn't too bad. I found x. It said solve, okay, the matrix equation. So I need all the variables. Well, all right, let's see what else has a variable. If I check this location out, I don't see any variables there. I don't see any variables at all. Okay, where do I see some variables? I got this negative 4, negative y. Okay, well, let's see. That would be negative 4 plus my negative y, and then I'm supposed to multiply that, because again, these parentheses are here, by that 3, and that should equal negative 24. This appears to be the same type of problem. Now I just need to solve. What? I divided by 3 last time. Maybe I'll do that here. Those will cancel. I'll have negative 4 minus y equals a negative 8. Well, I see those are all negatives. Maybe I'll just make them all positives. Subtract 4, and I get y is equal to 4. And that is how you solve a matrix equation. If you do not understand what I did there, pause the video, go back, try to listen to it again, and see if that'll help you out. Here is the next example I have for you. You're going to need to pause the video and make sure you have it written down. Now that you have it written down, it says find the matrix that makes the equation true. If I'm thinking about the matrix, if I'm going to add, I have an addition here. This is a 2 by 2. What must x be? Well, it has to be the same dimensions, so it's got to be a 2 by 2. Really, when I'm thinking about it, I'm thinking about x. You should be thinking x plus each element equals each element over there. So I have like x plus negative 5 equals 7. Well, solve that. I would add the 5 across, and I would get x equals 12 for this one. Now, what elements were I messing around with? Here I was messing around with, what, the first row, first column? Well, then that must be x sub 1, 1. And I can continue. I have x plus, okay, next one. That's 0, 0 equals negative 8. What element is this? Well, it's the first row again, so first row, x sub 1, and then the second column, so this is x sub 1, 2. Well, x plus 0, that's pretty easy. That's x sub 1, 2 equals negative 8. And then I'll just continue to work across. I have x again. This one, though, now I'm using the 4. Well, that's the second row, first column, so that's 2, 1, plus 4 equals negative 3. I subtract 4, and I get x sub 2, 1 equals a negative 7. And last but not least, I need to find x sub 2, 2, which would be plus a negative 3 equals 5. And then I find x sub 2, 2 equals 8. At this point, I have 4 x's. Should I have 4? Well, I need a 2 by 2. If it's 2 by 2, how much space is that? Well, that's 4. There's 4 elements. Okay, now I just need to put it in the correct order. This is key. You put a big X here for the matrix, and now I just fill it in. 1, 1. This is the first row, first column. Well, that's x sub 1, 1. That's my purple one there, which makes this thing 12. X sub 1, 2. Okay, first row, second column. That's that green one over there. That's a negative 8. X sub 2, 1. Well, that's that -7. And then finally I have my 8. And this is my solution. Alrighty. The last thing that we're going to do inside of matrices is we're going to multiply matrices. We need to multiply. This part here will be a little bit more difficult. Okay? It's important that you take really good notes here. When we're going to do this, we have to have the number of columns in the first matrix equal to the number of rows. Pause the video, write this down. Again, this is a great time. Pause the video, write this thing down right here. Okay, I'm not going to read this out to you. Great time, again, to pause the video here, write this, and then I'm going to talk a little bit about it. Now that you've had a chance to write this part down, it says, what are the dimensions of the solution matrix if it exists? So first I need to figure out if I can do this. If A is 2 by 3, well, this 3 better match that 3 over there. And they do. Because they match, I am allowed to do this multiplication. These match, so I can do it. Well, when they match, they actually essentially cancel each other out. So if I had a 2 by 3 and a 3 by 4, my final answer would actually be equal to a 2 by 4. Okay, let's do another one here. I'll scroll down. This one down here, I'm thinking about if I can perform this operation. Again, I'm checking the columns of the first and the rows of the second. Do they match? Yes, they cancel out, and I'm going to be left with a 5 by 5 matrix. So on and so forth. Here's a great time to pause the video and write down the example that I have on the board. Okay, now that you've had a chance to pause the video, okay, we are going to try to figure this problem out. I need to multiply. First, I need to see if I can. This is a 1, 2, 3, 3 by 1, 2. This is a 1, 2 by 1, 2. Oh, okay, 2 by 2. I'm asking myself if these match, which they do, they'll cancel out, and I should be left with a 3 by 2. So, I commonly talk about the answer being matrix A, just because it's nice, it's like answer, okay? Here I need a 3 by 2. That means 3 rows and 2 columns, which if I'm calling this A, that means this one would be A sub 1, 1, A sub 1, 2, A sub 2, 1, A sub 2, 2, A sub 3, 1, and A sub 3, 2. Okay, well, let's see if we can't figure out some of this. I'm going to erase some of the stuff that I have. Clean up my board a little bit. It says that the row, or the actual in value, tells you what you should do. Here I want the first row and the second, I'm sorry, the first row and the first column. Well, if I'm looking at this, this is the first row. And this is the first column. I am actually taking these, this 5 and this 2, I am taking it and I am multiplying it in down here. I am multiplying just like that, like I just moved it there. So when I'm doing this, I'm going to multiply those and then I'm going to add in between them. So let me show you what it looks like. I would have, over here in my work section, the first one up here is I would have 5 times 3 plus 2 times negative 2. First row, first column. Then I continue. I have first row, second, first row, second column. Well, the first row is still there, 5 and 2. The second column, though, is right here. So I'm taking 5 times 7 plus 2 times 0. And that should do it for the top. Then I move down to the next row, and I do the same thing. So I have 0. In this case, I would have 0 times 3 plus a negative 4 times negative 2. If I continue to work my way across, I would do the second column now. So that is 0 times 7 plus a negative 4 times 0. That would complete the second row. If I look at the last one, I would have this row, that's 1, 6. Okay, so I'd have 1 times 3 plus 6 times a negative 2. And finally, at the end there, I would have a 1 times 7 and a 6 times 0. If you look inside this little piece that I just made, this matrix that I just made down here, I'll cover everything else up. You can see the things in parentheses in the columns, straight up and down, match in the parentheses. So like this 3, I'll try to highlight it here. This 3 matches as I go down through. Just like the negative 2 matches as I go down through. Well, look up top here. That was the first column. And it's, again, in the first column spot right here. Okay, let's see if we're connecting some of these dots here. This is the second column. The second column contains, okay, 7, 7, 7, 0, 0, 0. Okay, let's look up top. Our second column right here was 7, 0. Okay? Does everybody kind of, I hope you're kind of seeing how that works there. Again, if you were kind of confused there, go back and watch it again. See it again. The same can be said, okay, the same can be said about the rows. Here I'm not going to highlight it, but you can see that I have 5, 2, and 5, 2. I'm not going to highlight all of them because I think it'll get a little too crazy with all the colors. But I have 5, 2, 5, 2, and I see in the first row I had 5, 2. And they should match. If you keep this structure, it's easy to check your work to see if you have the right numbers in it. It's easy to check it. Okay. All right, now I just have to simplify. I've done all the hard work. I just need to simplify this thing. Okay, I just need to simplify it. When I look at it, I'm doing 3 times 5. That's 15 minus 4. I should have 11. That is this thing right here. And keep going. Why don't you guys simplify the rest? When you come back and unpause the video, I will have my answers up. Now that we're back, we can see that I have my answer matrix. And if I were to ask you what A 3, 2 was, what would we say that is? Well, that's what, the third row, second column. Oh, well, that's where they hit. That would be the 7. So this would be 7. All right, that's how you multiply matrices. And I have one more example to do. This one right here. Pause the video, and I would actually like you to try this one out by yourself. This is going to be the last one. The video is running a little bit longer than I would like, but this is going to be the last one that I'll do here. Okay, now that you've had a chance to write it down at least, I would be trying to try this. Or maybe, better yet, why don't you just see if you can actually do it? Okay, so you pause the video and you check to see if this can be done. Let me check. This is a 2x2. This is a 2x2. This 2 and this 2 match. Cancels out, and I should be left with a 2x2 over here. Okay, I should be left with a 2x2. Great. Well, now I just need to go through and I need to try to complete these answers. I will try to color code this the best I can. I'll call this the green row. And I'll do this one as the blue. I will have the red column and the purple column. Okay, so my first one is A sub 1, 1. So I need the green and the red. The green would be 1 times 4. So I have a 1 times my 4. Well, my 4 is the red in here. And then I have to add -4 times my 0. And there I've done my very first element. Now I'll keep going. I have the green now and the purple. Okay, the green and the purple. Well, I know the green's going to be the same setup that it has now. So it's 1 something, -4 something, and I'm running out of space over here. I'll try to make this a little bit tighter here. This is 1 times something, and then I have a -4 times something. Well, the somethings are going to have to get added after I do this. And what are the somethings? Well, that's the next column, which is the purple. And the purple one is -1, -3. Okay, now I'll keep setting this thing up. So I'm done with the green row. Now I go after the blue one. Well, the blue row is 3 times something. A bunch of different colors there. Times something plus, okay, -2 times something. Again, same thing over here. 3 times something, -2 times something. I'm adding those. What are the somethings? Well, it's each one. This one down here, this section is the first column over here. Well, that's a 4. I want it to be red. 4, 0. And then I have the purple, because that's the second column, which is -1, -3. Now I have everything set up. All I need to do is simplify it. And I have for 1 times 4 is 4. And then I had 0 for the other one there, so that's just a 4. As I'm moving around, 1 times a -1 would be -1. -4 times -3 is 12. So I have -1 and 12. That makes 11. On the bottom there, bottom left, that's 12. Minus 0, so that's 12. I have -3 plus 6, which would be a 3. And there I have my answer matrix. And if I ask for A sub 2, 1, we would go second row, first column, and that would be the 12, so I could kick this out. Multiplying matrices is not easy. Okay, you should go back and rework the problems again and again. You should watch this at least 2 times. At least 2 times on the multiplying matrices. We will be working in class on doing this. Okay, but you need to come with your notes complete and ready.